Greetings, everyone. Today, my friend Dilhaq and I, Habib Abdelrahim, we will be presenting a review entitled Social Recommendation, published on 2030 by a group of Chinese and associate professors in the Computer Science and Engineer department. So for the outline, we will first start with an introduction. Next, we will have an overview about the recommendation system. Next, we will introduce the social recommender system, traditional recommender system versus the social recommender system, the positive and negative experience. We will also talk about some research direction for future work, and we will finish with a conclusion. So this paper is an overview, is a review, so it actually synthesizes the existing research in the field of social recommendation. So it summarizes the existing work and also states some research direction that can be used in the future work.
Thank you, Habiba. So the social recommendation system can be classified as follows. First thing, content-based, which is to recommend items based on user past behavior. To recommend them, we use vectors and weight. Second, collaborative filtering. In collaborative filtering, we have memory-based model and model-based. In memory-based, we have user-oriented method, which is we focus on the same item but different user. In item-oriented method, we focus on the same user but different items. Back to model-based. In model-based, we use models to generate the rating by applying data mining and machine learning algorithm. Finally, the hybrid, which combine the two previous one, collaborative filtering and content-based, to overcome their weaknesses. Back to you, Habiba.
Thank you, Thea. So now that we understand the different classification and the use technique in traditional recommender system, let's understand what social recommender system are. Actually, here the author summarized the definition in two. The first one is a broad definition, and the second is a narrow definition. The first one, our system that make recommendation to user based on social information, such as connection, a relationship, a preference, and other behaviors. So it's conjunctions with other type of information. It's not only about social information or connection. For the narrow definition, it actually uses only the social information. So the difference here is that the first one uses, let's say, other information such as the behaviors, the preference, etc. But the narrow use only the connections. For the social relation, or let's say the hypothesis of social recommender system, it's actually the work is based on the idea that the user tend to trust and to be influenced by their connection, their friends. So user preferences are likely to be similar to or influenced by their connected friend. They are correlated when they establish, the idea is that they are correlated when they establish a social relation. And in psychology, this is known as the homophily. Here we have some statistic about the idea of trust or the friend connections. We have like 66% of the people on social website have asked friends or let's say followers to help them make a decision or to make some recommendation about a product. We also have that 78% of the consumers trust peer recommendation, peer which means friend-to-friend recommendation over, let's say, the ads of Google's, etc. Now answering the question of what makes a social recommendation different from traditional recommender. Here we have the traditional recommender system. As you can see, we have the famous rating matrix. As presented, it makes recommendation based on the behavior of a similar user. Now, if we see the social recommender system, we can see that they have this matrix, the rating matrix, used in the collaborative filtering, followed by the user connection metrics. Here we have 0 to say that users are not connected, and 1 if users are connected. So the main difference here is about the input. For the traditional recommender system, we have one input matrix, and for the social recommender system, we have two input matrix that are the rating matrix and the connection matrix. But of course, the output is still the same. So it's a basic collaborative filter model with a social information model. So this part will be treated by my friend BA.
Thank you, Habiba. Now, how are we going to classify the social recommendation system? Well, since most of the social recommendation system use the collaborative filtering, we're going to classify it into two major categories, memory-based and model-based. In memory-based, we have tidal trust, which is a method that aims to make recommendation based not only on user preferences, but also on trustworthiness between the users and the item. Trust Walker will it use a random walk technique to find the most trustworthy individual in the social network and make recommendation based on their preferences. In model-based, we have cofactorization and regularization. Cofactorization is a technique used in recommendation system to combine multiple matrices into a single factorized representation. By regularization, which is a technique used in machine learning to prevent overfitting by adding a penalty term to the objective function being optimized. Benchmark. In Benchmark, we have Opinion 3, which is a website where people can review products. These datasets are very popular in recommendation system, which can be used as a baseline. We also have Flicture, which provide user item rating and user friendship network. We also have Chow, which is a website where user can rate and write reviews. Finally, Opinion 11, which is a dataset that contains rating and social information. Here, as you can see, we have different datasets like Chow, Opinion, Flicture, movie lens, number of users, items, rating, density. As you can see here, movie lens is not used for recommendation system since it does not have linked connection unlike the others. Evaluation matrix. Here we are going to measure the closeness of the prediction rating and the true rating. The smaller the value, the better. For ranking accuracy, here we are going to measure the effectiveness of social recommendation system by comparing the items recommended to the users and the item they are actually purchased. Key finding, positive and negative experience. From both positive and negative experience in applying social recommendation system, we seek to deeper understanding and further development of social recommendation. We have the data sparsity, which is the rating matrices. It is usually very sparse. Do most users rating few of the millions of items? It is forced to choose the neighbor in small portion comparable user, and it is probably going to miss other non-comparable relevant users. Cold start. Most of these systems are not able to generate accurate recommendation for users with a few or no rating. Social recommendation can make recommendation as long as the user is connected to a large enough component of social network. Recommendation can significantly reduce cold start users.
Thank you, DA. Okay, but social relation may be mixed with, let's say, useful information and nosy connection. Since in our network, we may have, let's say, valuable friends, casual friends, event friends. So users are not necessarily all dissimilar, and using all available relation may make your recommender system perform worse than any traditional recommender system. So the author here, to prevent that, it gives us some research direction in order to improve the performance of a social recommender system. The first direction, or let's say the first challenge, is the heterogeneity of a social network. Actually, let's say people do place trust differently to user in different domain. So for example, user one may treat her social relationship differently, which means she may take suggestion or let's say recommendation about sports from user one, but ask user, for example, 10 for a recommendation about the music. So this is what we mean about different domain. We should not trust one user for different domain. The second challenge is the, let's say, the temporal information. Actually, customer preference of product drift over time. It means it change over time. You may last year used to like fast food, but for this year you are into, let's say, healthy food. So it's drifting over time. The second one is the social relations that also do change over time. For example, user X may become inactive or let's say deleted from your social relation. And this is change of both rating and social relation actually do make recommendation very challenging and difficult. So the second, let's say, research direction is actually the cross-media data. By cross-media data, we mean the user data is existing in different websites. And it's normal for a user to have multiple accounts in social media. For example, a new user on a website like Amazon may have been existing on the Alibaba website for a long time. So the challenge is why not integrating all the information? So integrating networks from multiple websites can bring about a huge impact on the social recommender system and provide an efficient and effective way to solve, let's say, the cold start problem. For the conclusion, the social recommender system is still in development and needs further improvement. And in this paper, the author presents a general idea about the different recommender system, the social recommender system. He gives us some benchmarks to use. He also introduces some existing social recommender networks such as the trust worker, the trader trust worker, etc. And we finish with let's say research direction in order to improve the further work. So thank you for your interest.
Thank you.